Today our topic is inequalities in triangles, so our learning target is how can I use inequalities in triangles to find possible side lengths and make comparisons. First off, two theorems for you. Theorem 5.10 is if one side of a triangle is longer than another side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So here AB is 8 in length and BC is 5 in length, which means the angle opposite side 8, which is angle C, is bigger than the opposite angle to side BC, which is angle A. So angle C is bigger than angle A. And theorem 5.1 is just the opposite. If one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So here we have a diagram that just shows a triangle with its side lengths measured and its angle measured. So if you look at angle B right now, angle B is the largest angle, and if you look across from angle B, side AC is the longest side. So the largest angle always is opposite the longest side. Same with the smallest angle. So the smallest angle is over here at side C, which is opposite the shortest side, BA. So it doesn't matter what you do if you change it around. You make angle C the biggest angle, and it's going to be opposite the biggest side. So it always holds true, no matter what. Stage prop. You are constructing a stage prop that shows a large triangular mountain. The bottom edge of the mountain is about 27 feet long. The left slope is about 24 feet long, and the right slope is about 20 feet. You are told that one of the angles is about 46 degrees, and one is 59. What is the angle measure of the peak of the mountain? Well, we know triangles sum up to 180, so if we add 59 and 46, we get 105. Take 105 away from 180, and we get 75 degrees. Now, does that make sense? If this is 75 degrees, that's your biggest angle, and it would be across from your biggest side. So yes, that would work. Theorem 5.12, triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So the sum of the two lengths have to be greater than the third side. Now, before we do our example, let's talk about why this is. So right now, we can control the length of any sides of our triangle. So if we say that this blue length is going to be 10, right now the other two sides sum to larger than 10. 15 plus 8.3 is bigger than 10. Or 10.1. But if we make that sum not bigger than 10.1, all of a sudden the triangle collapses and it cannot be created anymore. 1.6 plus 8.3 is not bigger than 10.1. And if we keep going smaller, we don't have a triangle anymore. You only have a triangle as long as that sum is bigger than the third. Same with this side. If we take that side away, make it smaller, it doesn't work. As long as it stays larger, though, you can create a triangle. So, example 1, a triangle has one side length of 12 and another length of 8. Describe the possible lengths of the third side. So we have a minimum and a maximum side length. So you have to take the two side lengths and they have to be greater than the third side. So 12 plus 8 is going to be your max. So if we do 12 plus 8, that's 20. So X would have to be less than 20, because 20 is your maximum side length. Because the sum has to be larger, so 12 plus 8 is 20, so it can't be bigger than 20. We could have a side length of 19, but once we hit 20, the triangle would be no more. And then for the minimum, instead of adding the two sides, we'd subtract them. 12 minus 8 is equal to 4. So that is the smallest that side could be. So X has to be greater than 4 and less than 20. So if we wanted to write it together as a nice inequality, compound inequality, X needs to be between 4 and 20, where X is that third side. And we could even set it up here. We had one side length of 12. That's about as close as we could get to 12 right now. And one side length of 8. Okay. Well, that's pretty close to 8. So if we bring this up here to 19, but once we hit that 20, triangle is no more. We can be less than 20. You see that? But once we hit 20, a triangle goes away. So that's why we can't exceed 20. And then if we go down to 4, we can be bigger than 4. There's still a triangle there. Once we hit lower than 4, there's no more triangle. So that's why that inequality works. So you take the sum of the two numbers and then the difference of the two numbers. And it gives you your inequality. Hinge theorem, theorem 5.13. If two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. Just saying, if you have two congruent sides on a triangle, the one that has the bigger angle in between the two sides means that the opposite side is longer. Converse of the Hinge theorem, if you have two congruent sides, then you just opposite, so the angle is bigger on the bigger side. Example 2, given that ST is congruent to PR, ST is congruent to PR right there, and then also this side is congruent to itself. How does angle PST compare to angle SPR? So PST would be right here, and then SPR would be right here. Which side is longer? 24 is longer, which means angle PST is bigger than angle SPR. So we could say that the measure of angle PST is greater than the measure of angle SPR. And that would be by the converse of the Hinge theorem. Example 3, use the diagram at the right. If PR equals PS and the measure of angle QPR is greater than the measure of angle QPS, which is longer, SQ or RQ? So we know that these two sides are congruent. We also know this side is congruent to itself. And the measure of QPR, so this angle right here, is larger than the measure of QPS. So this one is bigger than this one, which means that this side, opposite of the larger angle, is going to be longer. So we can say RQ is longer than SQ. And then if PR is equal to PS and RQ is less than SQ, which is larger? Angle RPQ or angle SPQ? So we have, again, the side lengths are congruent. Two pairs of side lengths are congruent. We know that RQ is smaller than SQ. So which is larger? The angle that's across from the larger side, which is SQ. So this angle right here, angle SPQ, is going to be bigger. That's all the notes that I have for today. Thank you for watching this video, and please subscribe to my YouTube channel.